Hi everyone. In this episode, we are going to explore how we can measure the impedance of a ferrite core using a VNA or better, an impedance analyzer. Okay, impedance analyzer. In the previous episodes, we explored that the circuit impedance, the way you place your ferrite, and the way you configure your ferrite, whether in a single turn or multi-turn configuration, would affect its effectiveness, right? The insertion loss, as we often call it. One of the questions readers ask is, can we really trust the ferrite cores we bought in places like eBay and Amazon, where they claim to have certain impedance? How do we really know their impedance, right? Just really want to check if they are true with their words on the data sheet. In today's episode, we want to show you how to use a equipment often called impedance analyzer to measure the impedance of a ferrite core. You can also use a VNA, but VNA often does not give you the absolute value of Z, which is the impedance. So an impedance analyzer is a better option for such work. You can check the link. There's a link here, which Ferrite did, but in this episode, we want to cover some of the details that they didn't talk in measuring a impedance of a ferrite core. Okay, so quickly show you the setup. As you can see, this is a very old machine. This is probably more than 20 years now. It's from Hewlett-Packard, and this machine can do spectral analyzer, VNA, and also impedance analyzer. And the way we do impedance measurement is via this special jig here. Okay, just quickly show you what it is. Right, you can see this is a HP impedance test adapter. Okay, so it works with this VNA, and then on top of that, you also have this special jig, which is a bonding post fixture. Notice that there's a maximum frequency there, which is 125 megahertz, and also there's an electric length. Tells you it's about 0.34 centimeter as the electric length of this jig. What does this mean then? Well, we'll show you later. But the idea really is, say if you have a inductor or capacitor, leaded, let's say, you can then put this into this jig, fasten the screws, and then measure the impedance. But then obviously the measurement will only be limited to about 125 megahertz. And yeah, we're going to use this setup to measure a ferrite core, such as this small one, to see if it matches with the data sheet. Okay, so let's have a look. As with all the RF tests, the first thing we need to do is to calibrate the equipment. Okay, and the way we calibrate this impedance test adapter is through devices such as this. As you can see, this is a very delicate open circuit calibrator, right? Show you what it looks like. It's very delicate. You can see once I mount it on this, I will calibrate it as an open circuit, right? And this is a short circuit, so short, and then this is a 50 ohm. So we'll do open, short, and 50 ohm calibration on this reference frame. Okay, let's start. Okay, so after we calibrate the impedance test adapter, we're gonna mount this fixture on top of it. Okay, remember that this fixture has its own electric length. Okay, and we need to put this electric length of this fixture into the impedance analyzer. How to do that? Well, there's an option here that says fixture. So we do fixture, and then there's a modifying fixture. So if I go to modifying fixture, then I can define extension. So here you can see equivalent electric length. We know that this jig has 0.34 centimeter long. So all I need to do is type in this information. This is important because, as I said, for RF in measurement, we need all these details. Okay, so let me put 3.4 millimeters. Yeah, so that's 3.4 millimeters, 0.34 centimeters. Once that's done, and I'm going to connect this. Okay, so that's in, so that's DEL. Now the last thing we need to do is we also need to calibrate this fixture as well. So we go to Cal. You can see here is fixture compensation. So I do fixture compensation. Right. In this case, I also have three options: open, short, and load. Okay. So I'm going to do it again on this port here. So how do we do it? Well, for the open, I can just leave as it is, right? This is my open. I'll do an open. So I'll do open. Okay. And short, I need to shorten it using a small wire like this. So I'm going to short it. And essentially, this wire would be my wire also for measuring the small ferrites we talked about. So that's in. That's a short wire. Let me short it. Okay, then let's do a load. So here you can see I have three 150 ohms in parallel. So effectively I have the impact of the ESL, equivalent series inductance of these resistors, because I have three in parallel. So effectively I have a third of the ESL and a third of the ESL. But for because we're only measuring frequency up to 100 megahertz, therefore it's using this as a 50 ohm load is acceptable for this test. So let's do that. Okay, so that's everything done, right? So if I go to measure, then measure impedance, as you can see, I stopped at 200 megahertz, but we know that this jig works maximum to 125 megahertz. So let's just leave it as it is. So if I do scale, auto scale, yeah, that gives me a curve which is showing here. So if I have a marker, you can see this is roughly my 50 ohms as across the frequency. So that's my reference. Okay, so now let's put the ferrite in. So let's check this ferrite first. This is a small ferrite from Ferrite, and it's, as you can see, this is a 75 material. Okay. So this is the curve we plotted. Let's see, marker. We go to here. Let's have a look. Here's the impedance. So peaks about 4 megahertz, and it gives me the impedance value of about 105 ohms. And after this resonant frequency, the impedance started to drop quite sharply. So that's this low frequency ferrite performance. Okay, so now let's try the other ferrite, which is this one. 0431, so that should work up to hundreds of megahertz, isn't it? Let's try this one compared to this one. Okay, so that's in scale, auto scale. Yeah, so this is the new curve. Okay, let's have a look, marker. So this one definitely works very differently. So the impedance starts to increase quite linearly, and you can see definitely, because we stopped at 200 megahertz, this one would, the impedance of this ferrite would increase, and you can see at 162 megahertz, it's already 200 ohms, and it's almost flat now. So this setup shows you the correct, shows you the proper way of measuring a impedance of a ferrite core using a impedance analyzer. Now you may say that, well, I don't have this equipment and I don't have all this RF fixture, RF jig. how do I do it? Using, let's say, a low-cost VNA. We can do that, of course. Let's have a quick look. Okay, so here we move to my Siglent VNA. So again, this can do both VNA and spectrum analyzer. So I'm selecting VNA mode at the moment. The way I use this equipment to measure the impedance of a ferrite core is, if I show you, I'm using VNA, of course, and then I'm using S11. So I'm using S11 because it's measuring the reflection, so representing the impedance, input impedance of the ferrite core. And of course, I will need to do the same thing, the calibration, open short loads. Then I put the ferrite core using as a short wire, as short as possible on this sort of connectors, right? And yeah, and I have a Smith chart plotting here. And if you look at the Smith chart, what I can do is I can select marker, therefore I can then move my trace and I can track at different frequencies how the impedance change here. But obviously this is a Smith chart, so it represents the real, the imaginary, and the phase shift between them, but it's not as straightforward as the impedance analyzer. So I wonder how I can use this equipment to plot the impedance. It should be easy using some software function, but you know, I haven't figured out yet myself. So if you know the answer, let me know. But yeah, this is how I use a VNA to measure the impedance of this ferrite core. Okay, so that ends this episode. Let me know your thoughts and feedback. I'm sure you probably have better methods, and just let me know, and then we'll do another video if we have enough information from you. Okay, thank you.